Okay, then we got die casting. Die casting is where we got a die, which is quite expensive. Usually, just to give you an idea for the die to make a tiny part and a normal part cost in thousands. The good quality, it's because of the metal we use to form the die. It's very wear and tear resistance. Remember, we're putting molten metal, so it has to withstand that temperature. It has to have a property where it can dissipate the temperature. It can absorb the temperature as well to cool the metal as well. Uh, the good dies, they last like many thousand of the component. It can cost many thousand of the component. If if the components are not made of metal, obviously it will last more, and so on. Now, in die casting, the die is, there are two parts of the die. One is known as movable die, another is known as the fixed die. It has ejector pins which are used to open both components, and then we have a cavity. So this is the part that we're trying to actually make, which is in the middle shape of the, looks like an E. So you pour the molten metal from the ladle side, and then sometime the ram actually helps to push that in very quickly. When the ram push that in, the molten metals actually enter the cavity. Yeah. So the chamber where the metal stays is known as short chamber. When it enters into the cavity, we let it to solidify. As soon as it solidify, we use the ejector pin to eject the metals. All the die casting, they have at least two parts. Yeah. The ejection, all these things happen through an automated process. Now you can see here the die cast, these are the ejection pins, yeah, are in two different halves, and they are fixed together. The die cast can be used over and over and over again. Advantage of the die cast on top of, sorry, on as compared to the sand casting is a very good surface finish. Sometimes we don't have to perform a lot of secondary finishing process. Um, for if you're producing thousands, 10,000, 20,000, is more economical. It's give you good dimensional accuracy and good surface finish. Very thin um, sections can be formed, and sometimes we can accelerate the cooling. Rapid cooling is achievable. Sand, the cooling rate is slow. Metal are good conductors, good cooling rate. The faster the cooling rate is, the smaller the size of the grain, yeah, which gives them good strength. Okay, now disadvantage is limited to the metal with low melting points. Part geometry must allow removal of the die. For example, if you are forming different multiple parts, you have to remove, you have to open the die, and so on. Now, the other process is known as investment casting. Now, the first thing is we do is we create a pattern with a wax. Now, then this wax is usually dipped in the molten, not molten, like a slurry, liquid slurry, where we have like ceramic material. We make the slurry of the ceramic materials, and we dip the wax into that one, and we put the wax on the sprue. And when that thing solidify on top of these wax material, we actually put that in a furnace where the wax is melted. We remove the wax. When the wax is removed, we actually pour a liquid metal into it. The advantages of that one is we can achieve a very intricate shapes, very intricate size, yeah, very good dimensional control, very good surface finish. We can reuse the wax as well. This process does not require any machining. It's actually the final product you get. Now, disadvantages, multiple steps are required. high skill level, it is very expensive process in term of costing. Now, after the casting, general casting, there are certain secondary finishing process we have to do. Trimming, we remove the core, we have to clean the surface, and then we have to inspect it as well. The inspection is mainly non-destructive in nature, where we see like, is there any inclusion in it, is there any micro void, air bubble in it, which will affect the properties of the material, and so on. We can do the heat treatment later on to create the homogenization, where all the material have the same properties. Now, castings, when they're done, mostly they are heat treated afterwards to enhance their properties. Now, why we need to enhance the properties? Because the casted objects sometimes are quite brittle. So later on, you are performing machining. So when we doing the machining, we don't want them to break. So um, we perform that process. Sometimes we want to have enhanced properties, so we carry out some other type of heat treatment. So that's it. We want to have desired properties, so we do heat treatment. We want to make it ready for the machining process. We do heat treatment. Most of the castings are made up of like alloys. They are easier to cast and give you better properties. Why they are easier to cast? Because the melting point of the alloys are a lot lower than these pure components. So if you mix iron, if you have iron around, let's say, is 13-1400 degrees centigrade, pure iron, if you put aluminium, the melting point will decrease. Melting point of aluminium is around 660 degree centigrade. Obviously it will decrease. But if you have pure aluminium and you add iron in it, the melting point of aluminium will further decrease as well, from 600 to that one. This is metallurgical law, which says melting point of the pure elements is always higher than the melting point of its constituent. So it's alloys. So we do the alloying to reduce the melting point as well to a certain limits. Now, when we do the casting, it's classified as either the ferrous or the non-ferrous casting. Now, then we have ferrous. Ferrous is anything that contain ferrum, iron, and we have a different classification. Anything containing more than 2% carbon is known as cast iron. Anything containing less than 2% carbon is known as steel. Then we have a classification of steel as well. We have a low carbon steel, medium carbon steel, and high carbon steel. We will discuss that one when we do iron carbon phase diagram. Then we have different type of cast iron as well. We have gray cast iron, we have white cast iron, we have a malleable cast iron, we have alloy cast iron, we have nodular cast iron. Now, we also have cast iron, we all assume it's brittle, but there's a type of cast iron, it's known as ductile cast iron as well. We'll talk about that one in detail. Yes, so we have a malleable cast iron known as ductile cast iron. It's good castability is there. It has good ductility as well, and so on. And it's good for machining purpose as well. Okay, now then we got the ferrous casting alloys. For example, iron steel is casted initially. It's converted into different shapes and size, send it to different industries, which can convert into different sheets, tubes, pipes, rods. Pouring temperature is usually kept higher than the melting point. The reason is because if it's kept at melting point, as soon as it touches the die, the temperature is going to reduce a lot. So we want to make sure it's higher than that temperature. So there is some temperature loss, but it still has some fluidity. Molten steel has poor fluidity, so we have to remember that one. Molten steel can react with the oxygen that's present next to in the air. So straight away it will react, it will form the iron oxide. So if you are pouring a molten iron, it's reacting and it's kind of give you a very nice firework as well. Okay. Now, if we are pouring a metal and we assume that metal is very castable, we make sure the temperature, the pouring temperature is low, which means we are saving energy. Yeah. So temperature, we say is TM 660 degrees centigrade. That's the melting point of aluminium. Now, non-ferrous metal, they are lightweight, they are easy to machine, and their property can be adjusted by doing the heat treatment. Now, when we discuss non-ferrous have other properties as well. They are good. They got aesthetic look. They got good bearing abilities. They have corrosion resistance properties as well. Then these are issues with them as well, which is the cost and massive applications, obviously. Um, let's say we talk about zinc alloy. Zinc alloys are high castability. It's common use in die casting. It has a low melting point, which is 420 degrees centigrade. It has a good fluidity. Uh, it has low creep strength, so casting cannot be subjected to high stresses. Creep strength is it's a tensile testing at high temperature. So the material behave very differently at high temperature and cannot withstand high strength. Now casting, we said it can be used to produce complex parts, complex geometry, and so on. But there are few things we can avoid. We can have the simple mold making process. If we can eliminate the need of making the core, so if you're creating a hollow component, we need a core inside as well. And then if we can try to adjust the geometry, that the cooling rate is properly adjusted, so it can give us the high strength rating as well. When we pouring the molten metal, we need to make sure we avoid the sharp corners. Yep, because that's the area of the stress concentration. Um, we need to make sure we provide a certain fillet along the sharp corners as well. It's not only for the metal to flow, because when the metal flow, if the corner is sharp, it will create a very kind of non-laminar or turbulent flow. That turbulent flow can take away the soil particles if you're doing the sand casting. If not soil, if it's a die casting, it can damage the die, the corner of the dies as well. So we need to make sure we avoid these corners, the sharp edges, and so on. Now, depending on what process we use, we can achieve the dimensional accuracy. Sand casting, not that much. Die casting, yes. Now, sand casting doesn't give you good surface finish, but die casting and investment casting give you a lot better surface finish. Okay, all the sand casting, they can be, all the sand casting, they have a thing called segregation. We'll talk about that one. All the sand casting, we leave certain allowance for machining as well, polishing, machining, and certain secondary finishing. Typical machining allowance is around 1.5 to 3 millimeter. Now, if I show you the microstructure and what I meant by segregation, imagine we are doing the casting, and that's the sand casting. The die is on the outer side. When the material starts to solidify, it will start to solidify next to the boundary. And imagine this is steel. So what will actually happen is the first layer that solidify, steel, which is iron and carbon, which has a lower percentage of carbon. And the material that solidify next, which has more percentage of carbon. And as you move inside, because the yellow is the one that will